Hello, video number 3 in our second derivative series. This function is a quartic. By the way, apologies for speaking slowly. I am a slow talker and I'm also quite tired. It's fairly late at night. However, this video is going to be absolutely fantastic. We have a quartic function, as I just said, and it has 2 inflection points, which I have labeled here and here. One of them has a gradient of 0 and is called a stationary point of inflection. Right? You can see here we've got this inflection, but the gradient of the function is 0 at that point. The other one is a point of inflection. Why? Because we're going from concave up shape to concave down shape. But this one is a non-stationary point of inflection. All right. Here's the second derivative. The second derivative will equal 0 at both of those points of inflection. Okay, so where x equals 2, we get second derivative equals 0. Where x equals 4, we get second derivative equal to 0. Where we have concave up shape, that means the gradient itself is increasing across that domain, which gives us positive second derivative. Where we have concave down, the gradient itself, all right, is decreasing. Okay, not the function, the gradient. Okay, so concave down, we're going from a fairly steep gradient here to less and less steep all the way down to 0. So that's a decreasing gradient from 2 to 4, x equals 2 to x equals 4. That means negative second derivative. Then we go back to concave up shape and positive second derivatives. Okay. How are you going to distinguish between stationary and non-stationary points of inflection? We can find both points of inflection when the second derivative equals 0. Right. But for one of those points, the first derivative will also equal 0. And as you hopefully might realize, first derivative equals 0 when the gradient equals 0, and the gradient equals 0 for a stationary point of inflection. Right? And if we think about sign diagrams here, we could look at this min, local min at x equals 1. All right. If I was to draw a sign diagram of this for the first derivative, I'd be going from negative, right, downhill gradient, negative to positive, right? And that would indicate a minimum. Right? For this one here at x equals 4, what would the sign diagram look like? Well, at x equals 4, the first derivative is 0, but here I've got positive values, right, for my gradient function, positive to positive. And so I'd be able to identify from the first derivative and its sign diagram that this was a point of inflection. Okay. So the key takeaway for this video, I'll say it one more time. You can tell the difference between non-stationary points of inflection and stationary points of inflection by looking at both the first derivative and the second derivative. The second derivative, when you set that equal to 0, you will identify points of inflection. when you then compare that to the first derivative, right? If you have an instance where both the first derivative is black, second derivative is green, when they both equal 0, you must have a stationary point of inflection. Thank you.